So here we're going to talk about standard deviation for grouped data. So this is defined to be S equals the square root of the sum of the value minus the sample mean squared times the frequency, all divided by little n minus 1. How many are in the sample? Where x bar is defined to be the sum of x times the frequency over little n, and n is adding up the sum of all the frequencies. Okay? Okay. So you can also estimate let's actually go through this other part first. So let's use this formula. Okay? So say you have a data set, and our data set's 0, 0, 0, 1, 2, 2, 5, 5, 5, 5. Okay? So you have a data set and it repeats lots of values quick and often. Maybe the data set is counting how many kids are in a family or whatever. Common answer is 0, 1, 2. And so you get tons of ones, tons of zeros, tons of twos, tons of threes, whatever. But then as the numbers get higher and higher, then it's less frequently. So how do we compute this quickly? Well, let's set up a table. So I'm going to set up x values. Okay, all the possible x values we run into are 0, 1, 2, and 5. So 0, 1, 2, and 5. Then I'm going to do how many there are of each. So there's 3 zeros, there's 1, 1, there's 2 twos, and there's 4 5s. Okay. The next thing I want to do, well, I want to calculate x bar. So to do that, I need the sum of x times f. So I need an x times f column, and then I'm going to add them all up. And so if I do that, I get 0 times 3, which is 0, 1 times 1, which is 1, 2 times 2, which is 4, and then 5 times 4, which is 20. So if I sum up x times f, I get 0 plus 1 plus 4 plus 20 gets me 25. Okay, so that's 25 over n, which is the sum of f. And so if I sum up 3 plus 1 plus 2 plus 4, I'm going to get 10. And so if I divide, I get 2.5 for x bar. Okay? So now we can run through our formula. So let's calculate s squared first, and then we'll take the square root, right, to get s. Okay? So the first value is 0. So I'm going to do 0 minus x bar, which is 2.5, square it, multiply by how many zeros there are. There's 3 zeros. Then the next one, right, that's where that's coming into play right there. The next one is a value of 1, so 1 minus 2.5 squared times how many there are. There's just 1. And then the next one is 2 minus 2.5 squared, and there's 2.5 or 2 of those. And then the last one is 5 minus 2.5 squared times, and then there's 4 of them. And I divide that by the total n minus 1, which is 10 minus 1. And if I type that in my calculator, I should get 5.16 repeating divided by 9. Okay, so let's try that out. know that. So parentheses, 0 minus 2.5, close parentheses, square it, and then multiply by 3, then plus parentheses 1 minus 2.5, close parentheses, square it, multiply by 1, plus parentheses 2 minus 2.5, close parentheses, square it, multiply by 2, plus parentheses 5 minus 2.5, close parentheses, square it, multiply by 4. Hit enter. Ooh. Okay, so that's a little bit different. Make sure I typed all that in correctly. Okay, and then what I'm going to do is I'm going to divide that by 9, and I get the 5.16. Okay, so this is actually what it equals to. So the 5.16, and then if I'm going to take the square root of 5.16 repeating, I'm going to do second square root, second answer, and hit enter, and I get 2.27. So S is equal to 2.27 here. Okay? So you can also, so what I was going to go into earlier that now we'll go into is that you can also estimate, keyword is estimate, the sample mean. Best thing we can do is get an estimate of it. And the standard deviation by using midpoints. Of each class. So say you've got a frequency distribution and we don't have an x value, but what we can do is we can use the midpoints as our x value. Okay? So say there's a class, right? And it's like 1 to 10, 11 to 20, 21 to 30, 31 to 40. Okay? So we need an x value, we need an f, and then we need an x times f. And if we have that, then we can calculate all the things that we need to get there to standard deviation and our sample mean. Okay? So let's try it out. How do I get the midpoint of this first class here? The midpoint, the x value, is equal to the average of the limit. So 1 plus 10 divided by 2, that's 5.5. So 5.5, 15.5, 25.5, and 35.5. Okay? Now we're told the frequency in the first class is 10, the next class is 11, then 20, then 19. So when I multiply x times f, I'm going to get 55, 170.5, 510, and then 674.5. Okay? So if the n is equal to the sum of the frequencies, which is equal here, this adds up to 60. And then the sum of x times f is equal to 1410. So that means x bar, which is the sum of xf over n, is equal to 1410 over 60. I just take this number here and this number here, and I divide the two. And what do I get? I get 23.5. Okay? Now, I want to get, I want to get s, which is the square root of the sum of x minus x bar squared times f over n minus 1. So what am I going to do? Well, I need to bring this down here because it's kind of a long thing. The first x value is 5.5, so I'm going to do 5.5 minus the average of 23.5, square it. And then how many do I have? I've got 10, so I'm going to multiply by the frequency, 10. So I did the first one of those. Okay, so I did the first one of those. The next x value is 15.5, so I'm going to do 15.5 minus 23.5, square it, and then multiply by 11 because there's 11 of them. Then I have 25.5 minus 23.5, square it, times 20. And then last, I've got 35.5 minus 23.5 squared times 19, because there's 19 of those. And I'm going to divide that all by 60 minus 1, because n minus 1 there. Okay. So when I do that, the numerator I get 6760. Denominator is 59. Okay. So 6760 divided by 59 gets me 11457 and then 6. Okay. And so that's s squared. So s is equal to the square root of 6760 over 59. And if I do that in my calculator, I get 10.7. So this is about 10.7. Okay? So these are faster ways to calculate the standard deviation with large data sets that often repeat in values. So what's going on right here? So when you have data sets that there's lots of numbers that repeat, maybe it's better to set up some frequency table. That way you can use this quicker formula here. Okay. When we did that very first problem, introducing the standard deviation, this is the type of formula that I used. Okay, it's quicker to multiply by 3 instead of add it 3 times. Okay, and then this is our one way to do that with to find the mean and the sample standard deviation. It's just an estimate, because we aren't given what the values of the original data are. We're just told that in the first class there's 10 data points that are between 1 and 10. We don't know what those numbers are. Those numbers could be 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever. They could all just be 1, and then it's just 10 ones, right? So we don't know what it is, so the best guess we can do is the midpoint. And so that's what we adopt as our x value, okay? So that's the idea behind it. So it only gets an estimate of it.